Humanity has a littering habit. From the deep sea up into the sky. Space debris is now a well-established problem. Around 70% of the 20,000 satellites ever launched remain in space today, orbiting alongside hundreds of millions of fragments left behind by collisions, explosions, and intentional destruction. And the outlook is worsening year on year. For each satellite, ESA has to perform twice as many collision avoidance maneuvers than it did 10 years ago, with some operators reporting 2 such maneuvers per month per satellite. But the challenge we face now is nothing compared to what is to come. A new era is here, the commercial space race. Access to space has become faster, easier, and cheaper, and vast constellations of satellites are dominating entire orbits on a first-come, first-served basis. Current predictions indicate that by 2030, the number of active satellites orbiting our planet could reach 100,000. Every additional satellite burns new rocket emissions, increases collision risks, and stains the skies for astronomy. Humanity's exploitation threatens a common inheritance, a common benefit, a cycle we are not unfamiliar with. International regulations and space debris mitigation measures are limited, and we are only just beginning to see the consequences of this new, complex, and unregulated mix of institutional and commercial space activity. So, is this a crisis? In some orbits, yes. Above 800 kilometers, we cannot rely on the atmosphere to pull down debris for disposal. Once these high-altitude orbits have been littered with shrapnel, there is no going back. The problem is cumulative, and, with our current level of technology, irreversible. Application-specific orbits, such as the geostationary ring, are simply irreplaceable. The satellites that enable our modern lives are at risk. From navigation for global transport, to time synchronization for banking and finance, telecommunications, climate monitoring, air traffic control, and international communication. We need space now more than ever to address the climate crisis and predict extreme weather events. Sudden damage to these satellites could lead to blackouts and breakdowns with unforeseen consequences. A catastrophic chain reaction is not just a possibility, it is already underway. In some orbital regions, our behaviour really could see us run out of space. Space has so much value beyond satellite services. It has been an integral part of our culture for millennia, entangled throughout our science and philosophies, our religions and mythologies. Overwhelming our skies with satellites is putting ground-based astronomy and worldwide social and cultural uses of space at risk. All future generations deserve to wonder at the night skies, just as our ancestors have before us. The stakes are high, the challenge is daunting, but there is still so much we can do to ensure a sustainable future. ESA is imposing stricter rules on itself with the goal of becoming debris neutral by 2030. The agency is reducing the maximum time that its satellites can spend in orbit after the end of their mission from 25 years to 5. And developing more reliable methods for depleting excess fuel and battery power to minimise explosion risk. ESA is also designing measures to preserve dark and quiet skies by minimising the impact of satellites on optical, infrared and radio astronomy. But space exploration is a global endeavour for the shared benefit of humankind. The long-term sustainability of space will require action and change from both traditional and new players. Together, the Zero Debris community is working on new principles and technologies for minimising the creation of new space debris and improving our ability to track, monitor, and avoid the debris already in orbit. ESA is also working to establish the concept of an orbital capacity. This would evaluate the space debris generation risk associated with new and existing missions to help guide safe and sustainable operations now and in the future. Ultimately, ESA aims to treat Earth's orbital environment like an international nature reserve. What you bring in with you, you must take out when you are done, and to encourage others to do the same. In the orbits where a chain reaction of collisions and breakups has already begun, active debris removal will be essential. To prepare for this, ESA will begin to equip missions with systems to assist their removal if they are unable to remove themselves from orbit. True sustainability is complex, and rushed solutions risk creating the problem of burden shifting. Solving one problem can sometimes create another. For example, the metals and chemicals used in satellites are released during re-entry, and the impact that they have on the environment is an accelerating area of research. For objects that reach the ground, the current best practice is to let them pollute the ocean to avoid human casualty risk. So how can our use of space ever be sustainable? Space is currently a linear economy, one that starts with the construction of rockets and satellites and ends with debris. The ultimate solution would be the creation of a sustainable circular economy in orbit. To achieve this, solutions such as in-orbit servicing, refueling or reusing existing satellite platforms, or more ambitious and futuristic solutions such as orbiting recycling stations, will be necessary if humankind wishes to establish itself in Earth orbit, or even at the Moon, Mars and beyond for centuries to come. This is our chance to build healthy practices in space. Our time to act already came, and now the clock is ticking. Our world could look vastly different if our measure of success was maintaining a healthy, balanced relationship with an environment. Pollution isn't inevitable, but the choices we make today will determine access to resources for generations to come. Let's build good habits on and around the pale blue dot that future generations can be proud of. Habits that humankind can carry with it out into the solar system.